I'm here at Electronica 2024 with KV Bhaaskar. I want to ask him some questions about the show. This is a huge show for electronics industry. There's like 3,000 exhibitors. There's over 70,000 attendees. It's important for us to be here because of all the semiconductor companies, including AMD. So I want to ask you from your perspective, AMD's perspective, why are you here at this show?
Got it. First of all, thank you, Jeff, for having me here.
Sure.
So if you look at the show, it has a unique mix-up, right? It's been able to bring people from the embedded space, component space, as well as the system integration space. And this is where AMD customers are in the industrial and embedded space, right? So we are here as one of the only semiconductor companies that has the most diverse product portfolios, going everywhere, everything from CPUs, GPUs, FPGAs, and adaptive SoCs. And if you actually look back 2 years ago, AMD acquired a company called Xilinx. We are the FPGA leader in the world. And to Xilinx, industrial was a huge part of the business, right? And right now, as part of AMD, we are still very interested and investing in the industrial space. So we're here to just emphasize, meet our customers, and have a good time.
Excellent, yeah. Let's focus in a little bit on industrial. I know like AMD, of course, is involved in PCs and gaming, lots of big markets, data centers.
Yeah.
But industrial control, very important. Industrial control has been a market in the past that's very conservative. People didn't invest a lot of money, but I think now things have changed where things like predictive maintenance and advanced robotics, there's more of an argument to invest some money. From your perspective, how do you see that situation?
Got it. Yeah, right now the popular term is upgrade cycle. People are talking about AI PCs, people are talking about data center AI, right? But there's actually another upgrade cycle that's been going on behind the scenes, which is the factories becoming smarter, right? And those are driven by some of the trends that you mentioned, which is there's more vision-guided AI robots now, right? There's a faster need for machine automation. There's higher speed sensors in machine vision cameras. So all of these are driving this kind of upgrade cycle. But the key consideration of our customers hasn't changed, right? They are still looking for cost optimization. They're still looking for low power products. They're still looking for things that are adaptable, reliable, and that has something long life cycle, right? And to give you an example, we have been listening to our customers. Earlier this year, we announced a new product called the Spartan Ultra Scale Plus, which basically ticks these 5 boxes, right? So it's a cost optimized product. It is going to be available for 15 plus years. It is going to be power efficient and highly reliable product from us.
Yeah, that's interesting. A subsection of industrial control is like machine vision, and I know that's particularly suited to sort of the adaptive programmable logic FPGA stuff that AMD makes. Can you talk a little bit about that?
Yeah, I think I'll take a quick step back just to level set here on the machine vision, right? So if you look at a machine vision camera, it typically has a sensor that then is the data is being interfaced and acquired from that sensor. Then you need to do some form of pre-processing, post-processing, and then you're kind of doing AI or traditional OpenCV functions. And then what you're doing is you're using some high-speed connectivity to then send it off to the next stages in the pipeline of the overall machine vision system. If you look at a product like the adaptive SoC, it's a heterogeneous compute device. It has things like R cores, which are used for real-time application. It has the FPGA, which has the capability to interface with these sensors and process them in real time. It has, depending on the product, right? It has the NPU, it has AI engines, or it has FPGA that can do your CV function, that can do your AI ML. It has transceivers that can help you with the back-end transfer of the data, right? So the adaptive SoC really well fits the bill for something like machine vision cameras, but going beyond everything in the kind of that cycle, right? So if you look at the cameras, 3D vision sensors, depth sensors, frame grabbers, which is the back end of the machine vision camera, or things like your industrial PC, all of these devices can be powered through an adaptive SoC.
Excellent. Well, KV, thanks so much.
Thank you, Jeff, for the time.
Yep.